November 7, 1943, occupied France. Cold wind rolled across the grass at the Luftwaffe airfield near Caen as mechanics looked skyward. A lone American fighter descended through low clouds, engine sputtering, its polished aluminum glinting in the pale sun. The guards raised rifles, expecting an attack, but the aircraft didn't fire. It touched down smoothly, rolling to a stop beside a row of German Messerschmitts. The pilot climbed out and surrendered without a word. What stood before them was not wreckage or rumor. It was a fully intact Republic P-47D Thunderbolt, the newest American fighter in the skies over Europe. Within hours, it was surrounded by engineers and officers taking photographs, sketching, whispering in disbelief. They thought they'd captured a plane. In truth, they had captured proof of something far greater, that America's factories were fighting a different kind of war. By late 1943, the air war over Europe had become a daily storm. American B-17 and B-24 bombers thundered eastward from Britain, their contrails forming white scars across the sky. Below them, the Luftwaffe scrambled hundreds of interceptors to stem a tide that grew larger every month. Germany's fighter force still carried an air of confidence. Its pilots had dominated the early years of the war. Men like Galland and Marseille were household names. Their Messerschmitt Bf-109s and Focke-Wulf 190s ruled the mid-altitudes where most combat took place. But the arrival of a new American escort fighter, massive, radial-engined, and painted with the star and bar, had puzzled them. The Republic P-47 Thunderbolt looked absurd by German standards. It was heavy, nearly twice the weight of an FW-190. It climbed slowly, handled like a brick, and seemed unsuited for tight turning combat. Luftwaffe reports mocked it as Der Fliegende Amboss, the flying anvil, yet something about it unsettled them. The few Thunderbolts that escaped dogfights dove away so fast that no German pilot could follow. Even those hit by cannon shells often made it home, limping across the channel on one smoking engine. Still, German command dismissed it as another product of American excess, a blunt machine built by a nation that measured strength in steel, not finesse. That belief would soon collapse, because on that gray November morning, 2nd Lieutenant William E. Roach's Thunderbolt landed whole on their airfield, its powerful engine intact, its instruments untouched. For the first time, German engineers could open the machine and see for themselves what American industry had created. The discovery began not in the air, but in the workshop. The captured Thunderbolt, serial number 42-22490, bore the name Beetle beneath its cockpit. It was carefully towed into a hangar, the American insignia painted over with black crosses and yellow recognition bands. Within hours, Berlin was informed. An undamaged example of the new U.S. fighter had fallen into German hands. Orders came swiftly. The aircraft was to be sent to Rechlin, the Luftwaffe's secret test center north of Berlin, where captured Allied planes were studied in detail. Rechlin was the beating heart of German aviation science. Here, test pilot Hans-Werner Lerche had already flown captured Spitfires and Mustangs, evaluating their strengths and flaws. Yet when the Thunderbolt arrived, even the seasoned engineers were taken aback. It was enormous, a machine built like an industrial monument rather than a warplane. They disassembled panels, tracing complex wiring, studying its air-cooled Pratt & Whitney R2800 double Wasp engine, and marveling at its intricate turbo supercharger system. To men accustomed to Germany's resource-limited designs, it looked like something from another world. Its engine mountings were overbuilt, its armor thick, its systems redundant. Everything suggested a philosophy alien to German engineering, one driven not by scarcity, but by abundance. The Thunderbolt wasn't a prototype of genius. It was a product of scale, an aircraft designed for factories that could produce thousands, built from materials Germany could no longer afford, using alloys their smelters could no longer refine. For the men at Rechlin, it was an education written in steel and rivets. They had believed the war could be won through superior design and courage. But the Beetle revealed a colder truth. They were fighting an enemy whose greatest weapon wasn't a plane or a pilot, it was an industrial system without limits. Inside Rechlin's hangar, the Thunderbolt lay stripped like a dissected giant. German engineers moved slowly around its exposed heart, the Pratt & Whitney R2800 Double Wasp, an 18-cylinder radial engine that radiated sheer industrial confidence. Every surface gleamed with precision machining. No corners had been cut, no material substituted. Even the bolts seemed excessive. Hans-Werner Lerche, the Luftwaffe's chief test pilot for captured aircraft, described his first impression in his logbook. The cockpit could baffle even an experienced pilot. Every lever, every dial had a purpose, many unknown to us. He noted strange systems that did not exist in any German fighter. Automatic mixture control, a constant speed propeller with safety governors, a fully regulated turbo supercharger that adjusted itself to altitude. In Germany, such features were theoretical luxuries. Pilots managed throttle, fuel mixture, and boost by hand. The Thunderbolt did it all automatically, not to simplify, but to protect the engine from human error. The aircraft was not designed for experts. It was designed so that thousands of average pilots could master it quickly and fly it hard without destroying it. The materials told another story. The engine's turbine blades used nickel-based high-temperature alloys, metals Germany could no longer obtain. Exhaust pipes were lined with heat-resistant insulation, the same kind used in industrial turbines. Magnetos and spark plugs showed ceramic finishes smoother than anything in German production. When they fired it up for the first time, the hangar shook. The R2800's deep, even rumble seemed to mock the sharper bark of German engines. This was not an engine struggling for performance. It was an engine built to last, a symbol of excess transformed into reliability. Every system spoke of a nation whose factories had no shortage of skill, tools, or materials. For German engineers, it was not envy they felt first, it was disbelief. The Thunderbolt was proof that the Americans weren't improvising anymore. They were engineering from abundance. What the German engineers discovered beneath the Thunderbolt's panels went far beyond metallurgy. It was a glimpse into the American mind. Every cable, every component had been arranged for maintenance first. Large removable panels, quick-release fasteners, standardized screws. The aircraft could be serviced by ground crews with minimal tools, even under fire. In German designs, elegance had been a matter of pride. Mechanics needed training, precision tools, and patience. Each aircraft was almost handcrafted, a reflection of limited production and highly skilled labor. The Thunderbolt, by contrast, was industrial pragmatism turned into air power. It wasn't built to impress, it was built to endure. Engineers at Rechlin began to understand what that meant. The Americans weren't just producing aircraft, they were producing systems. The same rivet sizes, the same gauges, the same access panels repeated across thousands of machines. Entire wings could be replaced like components in a factory assembly line. This philosophy extended beyond design. The P-47's robust systems tolerated poor fuel, extreme cold, and long-range punishment. Damaged Thunderbolts often returned to base with sections of their wings missing, oil streaming from bullet holes, and still made safe landings. It wasn't artistry. It was reliability by design, and it changed how the Luftwaffe viewed its enemy. There was also a psychological shift. German test crews began referring to the Thunderbolt as der Amerikanische Hammer, the American hammer, not because it was elegant, but because it simply never broke. They realized that for every Thunderbolt shot down, American factories would build 10 more identical, precise, ready for war. For the first time, engineers who once viewed America as an industrial giant without finesse began to see something more dangerous: discipline through abundance. The P-47 was not just a machine, it was a message. A nation's will cast in aluminum, telling them they could not compete on genius alone, early 1944. The captured Thunderbolt, now bearing German markings T9 plus FK, stood on Rechlin's test runway under a thin layer of frost. Hans-Werner Lerche climbed into the cockpit, his notes carefully folded in his jacket. He had flown more than 100 aircraft types, British, Soviet, American, but this one was different. He described the startup sequence as a lesson in controlled violence. When the Pratt & Whitney R2800 came to life, it didn't snarl like a Messerschmitt engine, it roared with deep mechanical confidence. Lerche advanced the throttle, the aircraft shaking as if eager to break loose. The takeoff roll felt heavy, sluggish. Then, as the wheels left the ground, the Thunderbolt began to reveal what made it special. Below 15,000 feet, it was exactly what German pilots had claimed: cumbersome, slow in turns, inferior in climb. But as Lerche continued upward, the altimeter ticking past 20,000 feet, everything changed. The turbo supercharger began to sing, a rising whine behind the cockpit as it forced compressed air into the cylinders. At 25,000 feet, while German fighters like the FW-190 and Bf-109 gasped for oxygen, the Thunderbolt surged forward as if it had found a second engine. The climb rate steadied. Power remained full. The controls grew firm but responsive. Lerche pushed into a dive, and the airframe howled through compressibility, reaching speeds that would have shattered most German fighters. He fought the stick, recovering with both hands, sweat beading under his helmet. When he landed, the engineers gathered, notebooks in hand. Lerche simply said, "Above 20,000 feet, this aircraft dominates the sky." For the Luftwaffe's analysts, the data was irrefutable. The P-47 wasn't built to win dogfights, it was built to control the air that bombers needed. And at the altitudes where the war was increasingly being fought, Germany no longer had control. In the weeks that followed, German reports on the Thunderbolt circulated quietly through Luftwaffe command. Engineers compiled exhaustive notes, concluding that the P-47's powerplant was beyond duplication under current material restrictions. They could measure it, document it, and admire it, but not replicate it. The psychological impact ran deeper than the technical data. For the first time, Germany's finest engineers realized they were no longer comparing fighters, they were comparing industries. The Thunderbolt was not a single machine born of inspiration. It was the visible tip of a vast production system stretching from Buffalo to Long Island, from Detroit to Kansas. Every piece of it, engine, propeller, radio, supercharger, was built by a specialized company working in perfect coordination. The Germans tried to adapt. Some units modified their tactics, ordering pilots to avoid Thunderbolts above 20,000 feet. "Do not follow in a dive," one directive warned. "Their speed is greater than yours and recovery impossible." Others suggested developing new turbo systems for the FW-190D, but the metals and production capacity simply didn't exist. Lerche's reports from Rechlin became part of the internal Luftwaffe circular known as Circus Research, a traveling evaluation unit that demonstrated captured Allied aircraft to German squadrons. Pilots who watched the Thunderbolt's dive tests described it as unfathomable, incomprehensible. One officer noted that it seemed to ignore the laws of drag. By the time Allied bombing intensified over Germany in mid-1944, the message was clear. The enemy could build machines that performed at full power when German designs were gasping for air. And worse, those machines arrived in endless waves. It was not a single test flight that broke Germany's faith in its engineering superiority. It was the realization, shared quietly in hangars and briefing rooms, that the war of design had already been lost. The captured Thunderbolt remained at Rechlin for months, its silver skin dulled by German winter. Another example, taken later, joined it and was painted with black crosses for evaluation flights. These aircraft were redesignated T9 plus FK and T9 plus LK, operated by Circus Research, the Luftwaffe's special unit dedicated to showing front-line pilots how Allied machines fought. Wherever the Thunderbolt appeared, it drew crowds. Mechanics tapped its heavy skin, astonished at its durability. Pilots circled the cockpit, bewildered by the dense network of instruments. Many asked the same question: why build it so strong? The answer came not from engineers, but from experience. The Thunderbolt could escort bombers to the edge of Germany and back, shrug off flak, and dive at over 500 miles per hour. It could absorb punishment that would rip lesser fighters apart. And crucially, it could be built in thousands without exhausting the factories that made it. German intelligence officers admitted privately that even if they matched its performance, they could never match its numbers. The P-47 embodied the reality of total war, an enemy who fought with machines as relentless as its production lines. When Allied forces swept through Germany in 1945, American technical teams found the remnants of both captured Thunderbolts. The airframes were weathered, their markings faded beneath layers of dust and exhaust soot. Engineers from the U.S. Army Air Forces examined the meticulous German test notes, every figure, every pressure reading, every altitude logged with mathematical precision. The Germans had studied the Thunderbolt exhaustively, even down to the metallurgical structure of its turbine blades. But the notes told a silent story. They contained admiration, not replication. There were no blueprints for a German equivalent, no practical attempt to reproduce its systems. Even if they'd wanted to, the resources simply no longer existed. The factories were gone, the supply lines strangled, and the fuel reserves dwindling. When the Allies compared the captured reports to their own production statistics, the contrast was staggering. While Germany struggled to build a few hundred high-performance aircraft each month, American factories were turning out over 1,000 Thunderbolts, each identical, tested, and ready for combat. In the end, the Germans had indeed captured the P-47. But what they truly uncovered was the scale of a nation that had turned industry itself into a weapon of war. The P-47 Thunderbolt was never the most elegant aircraft of the Second World War. It lacked the beauty of a Spitfire, the grace of a Messerschmitt, the simplicity of a Zero. But it carried something none of them could match, the weight of a continent's industry behind it. To German eyes, it was crude, oversized, wasteful. Yet in its bulk lay the blueprint of modern warfare. The Thunderbolt proved that victory in the 20th century would not belong to the nation with the finest design, but to the one that could build excellence at scale, replicate it, supply it, sustain it. The engineers at Rechlin had measured every bolt and turbine blade, traced every circuit, and filled their notebooks with respect. One of them later wrote simply, "We were outbuilt." That sentence would echo far beyond the war itself. It marked the shift from craftsmanship to production, from genius to logistics, the beginning of a new era where the factory became the true front line. In the Thunderbolt's rumbling engine and heavy frame, Germany glimpsed the industrial future, a future they could admire, study, and even fear, but never rebuild for themselves.